So we're going to look at two different types of exponent problems. And in the first part of this, we're going to look at some different laws of exponents that involve multiplication. So this first example here, I'm going to show you sort of two different things here. One is sort of a longer way to work this out, and then we're going to talk about some shortcuts of some things involving exponents. So if you take a look at this example here, x cubed times x squared, just remember that exponents are a shorter way of writing a multiplication problem where you're multiplying the same thing to itself. So for instance here, x cubed really means x times x times x, and then x squared really means x times x. And a shorter way of saying x times itself 5 times would be to simply just say x to the fifth. So that's kind of how you would take something like this and you would work it out. The shortcut is simply to just say that when the variables are the same and you're multiplying, the shortcut is simply to just add the exponents. 2 plus 3 is 5, so that would be x to the fifth power. So you probably heard of some different things involving those shortcuts with laws of exponents before. A different example has two different variables in it. So once again, just talking about sort of the longer way to do this, if you take x squared b cubed, that's really a times a, and then b times itself 3 times, and then a b to the b squared. Just remember, this is really a to the first since there's no exponent there. So this would be a and then b times b. So when we're putting these together, you have here a times a and then times a here, that would be a cubed, and then you have 3 b's here, 2 here, that would be 5 altogether, that's b to the fifth. So once again, if we're talking about sort of doing the shortcut here and adding the exponents, if I take, for instance, the a's, I got a squared, a to the first, if I added those together, 2 plus 1, there's where a cubed comes from. And then if you take the b's separately, b cubed, b squared, 2 plus 3 is 5, that's where b to the fifth comes from. So once again, the shortcut applies just as long as you're only putting exponents together that are of the same variable. So with the next one here, now we have coefficients. We have numbers in front of the variables. So when we're talking about doing some different things with this, what we're looking to do here is we want to multiply together the things that are the same. So first let me start with 3 times negative 4. So 3 times negative 4, that's negative 12. And then if we apply the shortcut to the variables, x squared, x to the fourth, 2 plus 4 is 6. So x squared times x to the fourth would be x to the sixth power. So you get something like that when you have coefficients in front of the variables there. So if we take that same thing and we work in sort of a different, two different variables. So just remember with this that the number in front of this, this has negative x squared. Just remember there's a 1 in front of that x even though there's no number there. So if, once again, I multiply together the things that are the same, I got negative 1 times negative 2, that's positive 2. And then you have x squared times x cubed. So once again, variables are the same. I can add the exponents. 2 plus 3 is 5, so this would be x to the fifth. And then you have for the y's, remember this is y to the first since there's no exponent there. So you have y to the first, y squared, add those together, you get y cubed. And that would be the answer for that one there. So last thing here involving multiplication, and we'll get to a different sort of type of multiplication here, problem here in a moment, but if there's 3 terms, we're simply going to just multiply 3 terms together. So just like we did previously, I'm going to multiply first the numbers in front of the variables. So I got 5 times 3 fifths, and that's positive 3, and then positive 3 times negative 4 is negative 12. So just remember, if you're not sure how to do 5 times 3 fifths, there's 2 different ways you could look at this. One is you could put this in your calculator. You could do the alpha y equals for the 3 fifths, or if you're going to work it out, basically whenever you're multiplying a whole number to a fraction, you do the whole number, you times by the top of the fraction, divide by the bottom. So in this case you would say 5 times 3 is 15, divided by 5 would be positive 3, and then when I multiply 3 times negative 4, that's where the negative 12 comes from. And then as far as the x's go, I got x squared here, I got x cubed here. So once again, variables are the same, so I can add the exponents. 2 plus 3 is 5, so this would be x to the fifth. And then for the y's, you have here y to the first, and then y squared. 1 plus 2 is 3, so this would be y cubed. So just a couple points of note here when you're talking about multiplying with variables and exponents. So and this came up in a couple of the different examples that we had. So just note that you want to put a 1 in front of any variables that have no number there, and that came up in a couple of the examples that we did. And then also, if you have a variable that has no exponent there, that's also, you put a 1 in there. That's to the first power. So once you do those two things, all you're really doing from there is you want to multiply the numbers in front of the variables. Those numbers are called coefficients. And then you want to add the exponents of the variables that are the same. So that's just some different just steps to follow, some rules for when you're doing multiplication. So the other type of multiplication problem has to do with what's known, problems known as a power of a power. Sometimes they're referred to as double exponent problems. So when you have something like this, and I'm going to once again show you, this is how you would kind of work it out the long way, and then we'll talk about what the shortcut is. But if you take something and you square it, what you're essentially doing is you're multiplying it by itself twice. So when you have x cubed squared, what this really means is x cubed times x cubed. And if you think about what we just talked about with multiplication and the laws of exponents, whenever the variables are the same, you can add the exponents. 3 plus 3 is 6, so this would be x to the 6th power. So that's how you take something like this and work it out. The shortcut is anytime you have double exponents like this here, so anytime you have a variable that's taken to a power and then the whole thing is taken to another power, the shortcut is that you can multiply the exponent. So if I take this here, 3 times 2 is 6, so the answer to this would just be x to the 6th. And that's just the shortcut that's involved with problems like that. So if you take something like this, and now if we put a coefficient in front of the variable, all I want to do is take each of these terms one at a time, and I'm going to take them to the third power. So what I'm going to do first here is I'm going to take 3 cubed, so I'm going to do this, I got 3 cubed, and then I'm going to multiply that by x squared cubed. So all I'm really doing is I'm taking the two terms of the parentheses and I'm just kind of breaking it up into two parts. So 3 cubed, remember that's 3 times 3 times 3, so you can do that in your head or you can do that in your calculator. That's positive 27. And then once again, whenever you have a power of a power, double exponents there, the shortcut is to multiply. So 2 times 3 is 6, so this would be x to the 6th power. So the next example, just note that there's a negative in front of the variable here. So I'm going to do the same thing. I'm going to take this, I'm going to break it up. So I got negative 5 to the 4th power. Just note, because it's negative, I'm going to put it in parentheses here. And then I have, remember, this is x to the 1st power. So I'm going to do x to the 1st to the 4th power. So if you go to do this part here in your calculator, just remember to put the negative in parentheses. And when you do that, this comes out to be positive 625. And then here I got the double exponents. Once again, so the shortcut is to multiply it. 1 times 4 is 4, so this would be 625x to the 4th power. So that's the answer for that one there. So just note for this next example, you have two different variables. So I'm still just going to take each part, the 3, the x squared, and the y to the 1st. I'm going to take each part and I'm going to take them to the 3rd power. So I have here, I'm going to take first 3, and I'm going to cube that, and then I'm going to take x squared, and I'm going to cube that, and then I'm going to take y to the 1st, this goes here, I'm going to take y to the 1st and I'm going to cube that. So here I got 3 cubed, 3 times 3 times 3, that's 27, and then once again here just note the double exponents, I can multiply those together, this would be x to the 6th, and then I got y to the 1st, y cubed, 1 times 3 is 3, so that would be y to the 3rd power. So that's the answer for something like that. So just note that there's 3 parts, but the way that we're going to do it is exactly the same as if there were just 1 or 2 parts to it. And then this example here sort of incorporates what we were just talking about with some of the previous examples that we did with multiplication. So just think order of operations when you're doing something like this. I got to get an answer to the parentheses first before I can do anything with the multiplying. So when I go to do this, this is going to be 2 to the 4th, just breaking this up into 2 pieces, and then I have x to the 5th to the 4th. So I have something like this here. So 2 to the 4th, that you can do in your calculator. 2 times 2 times 2 times 2 is 16. And then just note here the double exponents again. I can multiply those together. 5 times 4 is 20. So 16x to the 20th is the answer to what's in the parentheses. Now I can take this and I can bring it down. So I have negative 4x here. So now when you get to this point, this is the problems that we started talking about, where you're just going to multiply together the things that are the same. So if I do negative 4 times 16, that's negative 72. And then I have here x to the first, x to the 20th. Remember, when you're multiplying, when the variables are the same, I can add the exponents. 1 plus 20 is 21, so this would be x to the 21st power. And that's the answer for something like that. So just make sure with something like this that you follow order of operations when you do that. So just a heads up on sort of the next sort of thing we're going to look at with exponents. We're going to do some different things with division, as well as some different things involving negative exponents in regards to division.